Hey, I'm Sugendran. I work at Yammer. So today I want to talk about a recent refactoring project I was on. And I kind of want to share what I thought went really well for us and the process we took that helped us refactor what was a core component or what is a core component of Yammer. Now, when we think about the internet and we think about all these cool websites, these cool dynamic websites that we have right now, we need to look back at the history. We look back and we say, XML HTTP request is 15 years old, right? We've been making AJAX requests for 15 years now. The battle between Firefox and Internet Explorer, that was 11 years ago, right? We've got websites out there that are a decade old. And in those websites, we have code that is a decade old. And you start in a job and you look at it and go, oh my God, look at the spaghetti. How does anyone work in this? But the reality is that code works. It does what it was built for. And people are very reluctant to change this. But as the JavaScript ecosystem progresses, we get newer tool chains, we get better tools that we can work with. It makes our lives better, and it makes our code more maintainable. So we want to refactor. And I kind of want to talk about what we've done at Yammer with regards to this. So first, some background. If you haven't heard of Yammer, we're an enterprise social network, but we kind of work a bit differently to our enterprise counterparts. We basically build everything as an MVP. So we will build out a feature that our product team comes up with, and we'll release that out to our clients in our A/B test system. And we'll look at engagement and retention and see how that feature has changed the use of our product. And the reason we do this is if you're building a feature and it doesn't add any value to your product, then why keep it? Why do you want to maintain that code going forward? So if a feature loses, we pull it out. And we might reiterate in the idea later on, but in a different form. Or if the feature wins, it'll stay in, and in the future, we'll actually go through and add more to that MVP. Now, if you do this for 5 years, it does take its toll on the code. There's always bits that are left behind, or functionality has changed slightly. People have re-architected things along the way to make their project a bit easier. And so what ends up happening is you have this mix of custom frameworks and open source. So anyone coming into the team has this massive, massive learning curve. They've got to first come to terms with all the custom frameworks that we've written, how they function, then look at the open source frameworks, which they may themselves have not used, so they've got to learn those. And then they've got to look at how the actual components hold together. So how do our views and our controllers and our models hold together? It's quite painful. And the team has recognized this, right? We've recognized that anyone coming in is going to have a hard time with this. And now that we have these modern MV something frameworks, why not move to it? It's a common pattern that most people understand, and anyone coming in is going to have is already going to have an understanding of how that works. But not just anyone coming in from outside of the company, anyone coming in from other teams. If the Ruby guys or Java guys want to add to our code, they're quite free to do that. And we shouldn't have a roadblock in place to stop them. So what we did was we landed on Backbone. We chose it because Backbone is not going to fight us if we want to only use a portion of it. And what we have been doing is moving all our views across to Backbone views, progressively. The one we recently did was the thread list. So the thread list is a core component of Yammer. It is the core component. It is the thing that renders the feed. It is the bit that shows our users the messages for themselves. It shows that it's the place where they do all the replies and the posting. It is the core piece to Yammer. It's also the place where we've had the most amount of experimentation. It is the place where every product person wants to work because that's the core piece, right? But the problem with this is it's become slow to work in. It's become really hard to understand how it functions. One of the big reasons for that is we had an asynchronous rendering process. So back when we had to support slower browsers on slower machines, we had to it was all about time to glass, and it still is time to glass, but back then it was about putting something on screen, even if the rest of the page is not usable yet. The user gets the feeling that there is performance. Now, if you look at today, we have faster machines, we have faster browsers. We don't need to resort to asynchronous rendering. And I should have said this before, but asynchronous rendering comes with a cost. It comes with a massive complexity cost. You've got multiple items you're putting on the page. You've got to put them in order, because there's no point rendering the first item and the last item and nothing in between, right? So this adds to your problems. Now, before we go too further, I just want to say, don't go hating on your past teammates, right? Past decisions were made for a good reason. Their code means you're employed right now. It may not be the code that you like, but it was the code that did the job that was needed at the time. So every time we have this refactor discussion, we also have a rewrite discussion. There's always the, I could have rewritten in 2 weeks, right? And maybe you could, but there's always things that you might have missed, right? And this is a tricky decision for everyone. For Yammer, not so much. For Yammer, we're pretty much always going to refactor. And the reason for this is the time to ship on a rewrite is much, much more important than on a refactor. If we are going to rewrite a component in Yammer, that means any other team that wants to work in that space, or any other team that wants to build on something in there or fix a bug, is going to have to wait till we land our rewrite. Are we willing to slow down our product development because we want to rewrite the code to make ourselves happier and make the code more maintainable? Probably not. But if we want to refactor the code, we can do this in a progressive fashion. We can do smaller chunks. We can ship more often. And that way, we're not going to block the rest of our team. The other thing to consider is, how much do you really understand your domain? Like, we've had 4 years of changes and bug fixes. So if we're going to rewrite, we can't always be certain that we've captured all the edge cases. And on to my next point. So working alone is definitely dangerous, right? This project was myself and one other colleague. And in Yammer, no one works alone. It's important not to work in a silo, because at the end of the day, I have some answers, I have some opinions. They may not be the correct answers or opinions, and it's always important to have someone to talk to about these things. But you can't just talk to anyone, right? You need someone who's got the context. Because if you're knee-deep in a bit of code, going up and talking to someone about that code and they have no idea what you're talking about, it's not going to help anyone. So having a team where it's yourself and a few others helps. And having someone who's as stubborn as yourself is really important. Because if you have teammates that are just going to agree with you, then you might as well be working in the silo. So the first thing we did before we even wrote some code was to try and understand the domain. Now, I thought I understood threadless really well. I'd worked in it for about 9 months before this refactor. I'd fixed a whole bunch of bugs. I'd gone through and added a whole bunch of features. But it wasn't until we actually did this week of research that I truly understood it. I truly understood the scope of what models were getting touched, what components depended on the thread list. And this week, even though we weren't programming, was a week well spent, right? If you are going to do a refactor, you definitely need to spend that time researching your domain. Spend that time not programming. Often when we reach for that code first, is where our problems start. The other thing we did was we talked to the team. So we talked to people that had done projects in this space, and we asked them what their problems were. When we did all our research, we ended up with a scope that was massive. And it is pretty much the case with every refactor project I've been on, right? You always want to refactor all the things, but you can't. You need to ship. So what we said was we were going to limit the scope. We wanted to ship a fixed product, right? We wanted to say in a few weeks' time, we knew what we were going to ship. So what we said we were going to do was we were going to remove the massive hierarchy. The thread list itself had this hierarchy where over time it may have made sense, but right now we're taking away all the extra features that the hierarchy allowed for. So we could actually just flatten the whole thing. But the other thing we did was we had an open question to the team. We said, what is the thing you find the hardest about thread list? And they came back and said to us, I don't understand how it renders. No one understood how the thread list got things on the page. And it was because our asynchronous rendering process was just so complicated. So we included in our scope that we were going to remove the asynchronous rendering. We're going to be explicit about how things ended up on the page. It should be easy to follow when a model comes in and the model updates, how that then changes things on the page. And aside from asking the team what they thought the problems were, it's also important to keep the team in the loop, right? It's no good landing a massive refactor and then having the team resent you because you've just gone and made their life worse. So what we did was we came up with our spec and we put this out to the team for feedback before we started. We wanted to address any concerns people had. We wanted to change our spec if they had better ideas than we did. And we also wanted to make ourselves available. So people were going to be doing work in the feed while we were refactoring. So we were available to answer questions. We were available to actually help on their projects to get them past any blockers that they were having. And this is really important, right? You want people to accept the change that you're pushing. So we had this plan. The first thing we did was we committed straight to master. We literally copied and pasted the classes, stuck them in a different namespace, and committed it right into master. Now, for me, this is really important. You want to be in master as soon as possible because you then have, the rest of your team has full visibility on what you're doing. But you don't want to leak, right? So that's really important. You don't want to leak your changes out into the rest of the world. So what we do is we put our code behind a feature gate. We use our A/B test system, which lets us only enable our refactor for ourselves. If you haven't heard of a feature gate before, it's basically a massive if statement that enables a code path for specific users. So I've worked in places before where we haven't had an A/B test system to enable features just for the developers. Instead, what we did was we hard-coded developer user IDs into the code, into an if statement. It's ugly, but it does the job, right? You're able to test things in production without releasing it out to everyone. Now, this was really important for us because we had 3 projects doing work alongside us. If we had done this in a separate branch and then 2 months in merged back into master, they'd have no idea what we were doing. We'd have to bring across all their changes, or they would then have to re-implement their changes in our new version. So we did that first commit. It was probably about a month till we actually merged back again into master, till we had a working version that we were happy that other people could use. But once we were back in master, we were merging back in every few days. The other thing we did was we forked the tests. Now, tests give you trust, right? They give you trust that you're not going to break functionality. You're not going to reintroduce bugs that were previously fixed. But we also said we were going to change the API. We were going to make this component easier to use, easier to understand. And so it was very clear that we were going to need a different set of tests for this new API. The underlying functionality was going to remain the same, but the actual way the component was instantiated, the models were passed to it, that would change. So we wanted a place where we could illustrate that, and we could do that. And so we forked the tests. And that way, both the old and the new component are still both under test. The other important thing is, if we were accidentally leaking out of our refactor, if our changes were leaking into the existing system, the old tests would track that for us. We would realize if things were breaking. Now, I understand there are people with legacy code that they don't want to refactor because there are no tests. And this was the case at Yammer, right? If you look back 2 years ago, there was pretty much no test coverage. But the team as a whole came to the conclusion that tests was something that we wanted. It was something that we knew was going to make our lives better. And so what we've done over time is every time we've gone and fixed a bug, every time we've gone and added a feature, every time we've touched some code, we've gone and added a test. And what that's meant is that over the last 2 years, we're now at 70% test coverage. When I looked this morning, we had 5,781 tests, unit tests, right? They take 70 seconds to run against Phantom.js, and they give us pretty good confidence in our code. One tool we used to get us there was Istanbul. So Istanbul is kind of interesting. It instruments your code, and then what you do is you run your unit test, and it'll tell you what branches are not covered. It'll tell you what paths are not taken. So if you look in this picture up the top here, the little red bit that you see is an if statement that was never tested. And the little highlighted yellow parts they're if statements as well, but they're actually just parts of our check. So the first part is always true, so the second part is never tested. And by progressively looking at Istanbul, we were able to improve our test coverage over time. You're not going to get perfect test coverage up front, right? It's silly to think that you will for your legacy code. But over time, you can definitely improve it, and you can get to a point where you are comfortable to refactor. So we still haven't written any code. What we did now was we understood the domain, we'd forked master, we'd forked our classes we were going to refactor. Now what we did was we stopped. And we stopped and thought about the API. How do we want people to consume this component? We sat in a room with a whiteboard. We argued for 2 weeks. We went away. We hacked up approaches. We'd come back. We'd argue. We'd hack up some different approaches, and we'd come back. And eventually, we came to an agreement on what was a suitable approach. There were some key points for us. We wanted to be explicit. We didn't want to repeat past mistakes. We didn't want to prematurely abstract things. And we didn't want to introduce complexity where complexity was not needed. So one of the tools we used to track complexity is Plato. Plato is kind of interesting. It'll run on your code base, and you can track complexity over time. Now, if you haven't dealt with complexity before, complexity is this computer science term. And it's an indicator of how maintainable your code is. It's an indicator of how predictable your code is like. Sorry, not predictable is not the right word. It's an indicator of how many bugs you're likely to have because of unexpected behavior. And basically what it measures is the number of paths in your code. If your code has many, many paths, then you are likely to introduce unexpected behavior. If your code only has 1 or 2 paths, then you can predict what's going to happen pretty reliably. Now, we wrote a bunch of code, we refactored it. Should we just keep going? We can add a bit more refactoring in there, right? No, you can't. You set the scope way back at the start. You need to ship. Don't let your scope creep. Don't let your scope creep. The reason for this is you're going to get diminishing returns the longer you refactor. You want to ship sooner than later, right? You want to have people using your new code. You want to get feedback from them because things may change. Maybe you didn't have the completely correct approach. So what we did was we removed the feature gate and enabled it for everybody. We think the code was easier to understand, so we were quite happy with this, right? Now, you'd think we'd have this massive long tail of bugs. It's generally true for most refactoring projects that when you release it, you've probably missed some weird edge case. You don't quite know what happened. You didn't have a test for it. But you can avoid this. Because we were in master early and we were behind a feature gate, what we were able to do was open up our A/B test to all of Microsoft. We were able to do it an internal dogfooding effectively. So we spent a month on Microsoft before we pushed this out to production, or out to the public, rather. And by doing this, we were able to find features that we missed. There's a little link at the bottom of the feed that actually sends users to the top of the screen. And as engineers who use their keyboard to navigate around, we've never touched that, right? We never ever saw it. But within a day of releasing it to Microsoft, we were able to find that bug. Now, I worked in places before where I don't have a large organization to test my refactors. But what I do have are salespeople and marketing people. And all they want is they would just want the product to work, right? They don't care what the code looks like. They just want the features to work. So use them. They're perfect testers. Release early and have others find your bugs. All those things that you wanted to work on, write them down. There are going to be future refactoring projects, without a doubt. If you write them down now, then future teams will have a head start. They'll have a head start on creating their spec, and they'll have a head start on their domain that they need to cover. So before and after, we end up with 40% less code. We removed the asynchronous rendering, so it was very explicit as to how rendering worked. Was it successful? It's very subjective. I mean, we were talking about how easy is it to work in this space. We asked a bunch of teams that were doing work, and we've had positive feedback all the way. So we think we were successful. There was an interesting side effect. So this graph shows feed rendering times broken up by percentile ranks. The purple line up there is the slowest 10% rendering, sorry, the users with the slowest 10%, right? What happened was, with the asynchronous rendering, other things in the page could take the thread, right? Other animations, other pieces, other components rendering could steal the thread. And what would end up happening was the feed list would have to wait longer before it finished rendering. Now with a linear rendering system, or a synchronous rendering system, we have a predictable rendering profile, which means 50% of our users had close to no change in performance. But the 50% that had the slowest performance were actually much, much better off. So from our point of view, Refactor was quite successful. Thanks. Questions next door.